and welcome to the open classroom. My name is Mr. Forrester and I have a lesson for you all today to help you all out. So today the lesson is going to be focused on fractions. So you would have started fractions in previous classes and we're going to go over it and go into a few new things hopefully and try to make sure that you have that information in your mind. So specifically today we're going to talk about what a fraction is and what the parts of a fraction are going to be. So any fraction and all the different parts that it has, we're going to talk about that. We're going to form a few fractions and we're going to talk about something called set fractions. Good? So those are the three main things that we're going to be talking about today. Right. So as I asked before, what is a fraction? So a fraction is a part, amount, or proportion of a whole. So any broken off section, any separate parts, any equal parts of any whole thing that you may have, that can be considered a fraction of that whole. So we have an example, we have a pizza. So the pizza there, when it is uncut, or when you haven't started eating it yet, that is the whole. And if you decide to take one slice out of, let's say it has 10 slices in that pizza, and you take one, you took one out of the 10 total parts. You ate a fraction of that pizza. So the pizza is the whole, the part that you eat is the fraction, and the part that you have remain will be a separate fraction for the remainder portion. So when you are writing fractions, this is what they tend to look like. So these are an example of how you would write fractions. So you have a number on top, we'll get to what that's called in a while. You have a line, you have a number below. So we're going to go through and we're going to talk about it part by part and see if we can understand what each one of these different things in all of these fractions actually do, or what they tell you about. So as I mentioned, there are three main parts to a fraction. So this is what a fraction looks like, and we have a 3, a line, and a 5. In this fraction, that 3 is something called a numerator, right? So you have a numerator. We have the line in the center, that's called the vinculum, right? So we have the vinculum, we have the numerator. And the 5 here on the fraction, the bottom number on the fraction is called the denominator. So we have numerator on top, the vinculum line in the center, and the denominator at the bottom. But just knowing the name of it isn't going to help us much. So we're going to get into what the three different things actually do and what they stand for in our fraction. Good? So keep this image in mind and keep those names in mind, because that's what we're going to be referring to them from now on. So we're going to start, not at the top, but we're going to start with the denominator. There's a very specific reason for that. So the denominator is that number at the bottom of the fraction that we saw before. So the denominator, as I said, the number at the bottom of the fraction, it represents the total number of parts that make up the whole. So we were talking about a pizza before. So that pizza had 10 equal parts. Those 10 parts would be your whole, and that would be the number that represents your denominator. So I have a number here, a fraction here. We have 2, we have the vinculum line, we have 4. That 4 there, that denominator tells us that whatever our whole is, there are 4 total equal parts in that whole. Good? Very good. So that will be, like we have this circle here. So you see the circle is cut into a total of 4 parts, right? 1, 2, 3, 4. And that will be our denominator. Now the vinculum. The vinculum is a horizontal line. Now, I hope you know what the horizontal actually means. So it's a line going across, it's a line like the horizon. I would have mentioned it at some point. Right? It's a horizontal line that is used to separate the numerator and the denominator. So I know we started from the denominator. So we have our denominator at the bottom, vinculum line, and then we will have our numerator at the top. So we have our same fraction here. 2, vinculum line, 4. The final part of the fraction that we're going to be talking about is the numerator. So the numerator is the top part of the fraction. It represents how many parts of the whole are being considered. So what we have here is we have our fraction that we have been dealing with. We know that 2 is our numerator, right? And we have our circle here cut into 4 equal parts. In those 4 equal parts, if I were to tell you, make a fraction out of the portion that has been colored, good? So we have 4 equal parts in total, and 2 of those parts have been colored in. So numerator would represent those 2 colored parts, and it would be, of course, 2. So a fraction becomes 2 out of 4 equal parts, and it's written as you will see it here. Good. So again, when you're forming your fractions, this little pizza we have here, we have 1, 2, 3, 4, 5, 6, 7, and there would have been originally 8 equal parts of this pizza. But somebody decided that they wanted to eat 1. So they took a slice and they ate that slice. How many slices of pizza did they eat? They ate 1 out of 8 equal parts, 8 equal slices of this pizza, and that will be the fraction here. But you could also do the reverse. So if I told you, okay, James had a pizza, the pizza had 8 slices in it, James ate 1 slices, form a fraction from the amount that is left. Then now you're not considering how many pieces have been eaten. What you're thinking about is how many pieces you have left. So if we're forming a fraction from the pieces we have left, our denominator would be the same because the pizza still had 8 equal parts to start. Venculum line remains in the center, but the numerator will have changed. So instead of being 1 out of 8, now it will be 7 because you're talking about the parts that you have left. And if you don't believe me, count the slices that they are remaining. 1, 2, 3, 4, 5, 6, 7 slices remain. Our numerator would have to be 7 in that instance. So it really depends on what you're being asked for. That is how you will know what the fraction is and how you will have to form it. Good. So finding our denominator now. So in order to find your denominator, you count the total number of equal parts that make up the whole. This number will be the denominator. So if they give you a shape or something with 57 equal parts, then your denominator will have to be 57. If it's 4 equal parts, it has to be 4. If it's 8 equal parts, it has to be 8. Whatever the total number of parts in that whole is, that is what you have to use as your denominator. Good? So what I have here is I have a few shapes. We are going to form denominators out of the parts of that shape. Good? So what I want you to do is count the total number of equal parts in the different shapes. We'll be starting with the circle and we'll be moving on. So our denominator and our venculum line will come up, so you will see if you had it correct. First one now. How many equal parts are you seeing? You have 1, you have 2. So it looks to me like you have 2 equal parts. So our denominator would have to be 2. Simple and easy as that. You count the numbers, the amount in the whole, and you have found your denominator already. So let's go on to the other one. We have 1, 2, 3, 4 equal parts there now. So our denominator will look something like, good. So you have your venculum line, you have your denominator, half of your worries already finished. How many would the other one be? Good. So we have 3. Now we have a triangle. It's cut into how many equal parts? 1, 2. So our denominator will also have to be 2. So now we have a circle that's been cut into quite a few parts now. So take your time, start on one and move on. I'll give you a little chance to make sure. So go all around and let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 equal parts. Over there we have 1, 2, 3, 4. Very good. For this, another circle cut differently. We have 1, 2, 3, 4, 5 equal parts. Square, sliced up a bit more in a different form, but in this case we still have 1, 2, 3, 4. And for our last one, our last circle, it's been cut into 1, 2, 3, 4 equal parts. So I hope that you managed to find all of the denominators and that you have them in your head. So this is how you do it. As I mentioned before, no matter how many parts you have, to find your denominator, you count them up. How many, the total number of equal parts that you have in whatever that is you're dealing with, that is your denominator. It's as simple as that, really and truly it is. Right. So we can find the denominators. We figured out that you just count the total number of equal parts. Now you have to find the numerators. So finding the numerators is a little bit different because you don't just count up everything. It depends, as I mentioned before, on what you are considering. So we are counting the shaded portion or the colored portion, depending on how you will see it, to find the numerators. So the numerator goes above the venculum line. So you have numerator on top, venculum line, denominator at the bottom. We know how to find the denominator. Let's count the shaded portion and keep that in mind, the shaded or colored portion, to find the numerators. Good. Same shapes, right? Same thing from before, so we know what the denominators of these would look like. But we are finding the shaded portion. So you have the circle to start, and it looks like out of the 2 equal parts that we would have found before, looks to me like only one is colored. So numerator would have to be 1. So numerator is 1, our denominator is 2. So it's 1 out of 2 equal parts, and that fraction has a special name, but we'll get to that in a bit. So on to the square now. So we know that the square from before would have 4 equal parts, so we know what the denominator looks like. How many parts of it has been shaded or colored in? Good. So there's only, just like with this one part that has been colored in, but the fraction still looks different because the whole was different. So in the circle, we only had 2 parts to begin with. In the fraction, it has 4. So denominators are different there. But even though our numerators are the same, the fractions are different. And just like this one, there's a special name for that one that we'll be talking about in a while. So out of the 3 equal parts of the circle, how many have been colored? Good. So 1 once again. So 3 different fractions, 3 different denominators, same numerator. Fractions are still different. Good? Right, on to the triangle. How many total with our denominator is 2, and how many parts have been colored in? Right, again. So now is where it changes up a bit. Because we have our circle, and if I'm remembering correctly, there were 12 parts in this circle. How many have been colored in? So 12 equal parts, how many have been colored in? Count them. And see if you're getting it correct. So this fraction will be, good, so we have 6 out of 12 equal parts in this case. So the fraction has changed again, right? It's now 6 out of a total of 12 parts. 6 out of 12 equal parts. Next one, numerator would be 1. So it's 1 out of 4 equal parts. Again, different form of shape, same fraction as with the square above. But it just depends on how much your whole was and what your numerator is going to be. So we have our circle here, 1, 2, 3, 4, 5 for our denominator as before. And how many parts have been shaded? Just 1. So this one will be 1 out of 5 equal parts. Different denominator again, and our numerator is 1. So if there were 2 parts that were colored in, it would be 2 out of 5 equal parts. If there were 3 out of 5 equal parts. It depends. You have to count it. Next one. How many? Good. So we have 2 out of 4 equal parts there, and it's going good. And for our final one, 4 parts in total. How many have been colored? 1, 2, 3 out of 4 equal parts. So good. So we can find our denominator. We can find our numerator. Excellent. So as I mentioned before, some of the fractions have special names. Good. And those names, like as I was saying, 1 out of 2 equal parts. Right. I said it like that for a specific reason. So 1 out of 2, or 1 out of 2 equal parts, is called a half, 1/2, right? So it's cut into 2 equal parts, and one of those parts are being considered for whatever it is we are dealing with. So if you have a pizza, again, we're using the food example because Sue is hungry, and you have cut that pizza into 2 parts. Each of those parts will be a half. Good. So now we have the 1 out of 3 equal parts. It's called 1/3. Good. So unlike with this one, with the half, this one you can't have more than 1/3 here before it becomes a whole. So if you have 2 out of 3 equal parts, it's 2/3. Good. So it depends on, again, what is being considered, whatever it is you're dealing with. So it's cut into 3 equal parts, or 3/3. Good. Now we have 1 out of 4 equal parts, 1/4. So that's when it's cut into 4 equal parts. And again, you can have 2/4 or 3/4. And I'm sure at some point you would have heard that mentioned by somebody at some point in time. You just need to be mindful of it. So what it is out of 4 parts, and it depends on how much is being considered. It'll be 1/4, 2/4, 3/4, and so on. Good. So there are a few others with some names. So we have 1/5. That's out of 5 equal parts. So the 5th is the more important part there because it's out of 5. It's telling you it's out of 5. Because that 1 could change. So it could be 2/5, 3/5, and so on. So we have the 6ths. So we have 4 6 here because they are out of 6 equal parts. 4 have been colored. So 6ths there could be 2, could be 3, whatever. We have 7ths. So we have 1 out of 7 here, but it could, again, 2, 3, 6, how many ever you're considering. We have 3/8, 3 out of 8 equal parts. 2/9, 2 out of 9 equal parts. And we have 1/10, 1 out of 10 equal parts. Just like with the others, you can go on, so you can have 2 and 3 and 4 out of whatever. Good. So you might be asking a question because in our slides so far, what we've been using is a lot of shapes. So you might want to know if there are any other things that can form fractions, and yes, this is where the other objective is talking about set fractions. So there are other types of fractions. It doesn't always have to be a circle or a triangle or a pizza, right? It can be something that isn't one necessary whole piece but forms part of a whole, right? So one of the examples we're going to be dealing with is marbles. So marbles are not all joined together. They are separate different things. But if you have 4 marbles and you decide, and your fraction is going to consist of that, and you're considering 1, it can still be 1/4, right? It doesn't have to be of one whole singular thing. It can be as part of a set. As I mentioned, the marbles before. So it can be a portion or a set of objects. Good. So what we're going to be doing is we're going to be making that fraction out of this set. So we're going to find out 3 different things. We're going to find out what our denominator is going to be, and we're going to find our numerator using those blue marbles only. So we are considering the blue marbles and making a fraction out of that set. And we're going to see what that resulting fraction is going to be as well. Good? So first thing we have to do is find our denominator. So to find our denominator, again, just like with the shape before that was cut into different parts, we have to count the members of this set. So our marbles are the set. We have to count the total number of marbles in this set. So count along with me and see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since our set has 10 parts, our denominator would have to have how many parts? 10 equal parts as well. So denominator here, 10. Right? We have 10 marbles. 10 is our whole, because that's the total number of marbles in our set. That's what we're working with. Now, for numerator, we are forming a fraction out of the blue marbles. Good? So since we're using those blue marbles, we have to count only the blue marbles. Good? So let's see. Not blue, not blue, not blue, blue. So we have 1. And in addition to that blue one, we have, seems like it's 1 more. So I've counted 2 marbles. I don't know if you see 2 more blue marbles anywhere there or anything to that effect. But from my point of view, I see 2 blue marbles in total, and that 2 will be our numerator. And our fraction, or resulting fraction, will look something like this. So we have 2 as our numerator, we have our vinculum line, and it was out of 10 equal parts. So that fraction, if you remembered from previously, would be 2/10. Good? 2 out of 10 equal parts. Very good. 2/10. Right. So we're going to make a few fractions now using what we have learned so far. So we know how to get our denominator, we know about our numerator, we know what our vinculum line separates, we know how to count, we know that it does not have to be a shape, it can be a set as well. So let's try a few. We will try some with pictures of shapes. We will try some that will be from a set. Right. So this time, remember last time we spoke about the colored or the shaded portion. This time, careful of the word, we are using unshaded. So previously we did shaded, this time it's unshaded. And this is something that I have seen as a mistake that I want you all to try to avoid. Read through the question. If I ask you for the shaded portion, count the shaded portion. If I ask you for the unshaded, give me the unshaded. That's a mistake that I have seen, unfortunately. So let's see. Good. So we have a few shapes here, and we're going to run through them. So I need you all to count. I need you all to form your denominators, your numerators. Hopefully you have a pencil, a page, something with you right now to be able to put it on to make sure. So first one. Our first shape, we have a circle cut into how many equal parts? 2. So would that 2 be our numerator? Would it be our denominator? Good, that 2 would be our denominator. And since it's one part of that circle that has been colored, then it would be 1 out of 2 equal parts, or 1/2. So 1/2 of that shape has been shaded or colored, and the other half has remained unshaded or uncolored. Next one now. This circle has been cut into how many equal parts? 3. And how many of those parts have remained unshaded? Let's see. Write your fraction down. You could have it there one time. Remember, we're dealing with the unshaded portion now. Good. So 1 out of those 3 equal parts, or 1/3 of that circle, has remained unshaded. Write down your fraction for the other one now. Remember, unshaded. See if you get it right. So we have 2 out of the 4 equal parts, or 2/4, that have remained unshaded. Excellent, we are going good so far. Next one, count your parts, get your denominator, count your unshaded, write your numerator. Let's see if you'll get it. Right, so 3 out of the 5 parts, 3 out of the 5 equal parts have remained unshaded, uncolored. Next one, we're going good. Nearly done. How many parts? How many have remained unshaded? Let's see. So we have 3 out of the 6 parts in that circle unshaded still. So 3 out of the 6 equal parts, or 3/6, have been unshaded. Next one. Let's go. Count them up. It's getting a little harder now. Let's see if you all got it right. This time we have 3 parts unshaded. So that's our numerator, but it's 7 equal parts. So it's 3/7 of that circle have still been unshaded. Good. On to the blocks now. First one will be A. See if you remember the name. Right. So the first one is 1/2. Second one, out of 3, it's 2/3 this time. So we had 1/3 of the circle remaining unshaded. We have 2/3 of the block remaining unshaded. Next one. How many have remained unshaded here? Good. So we have 1/4 of that square unshaded still. Next one, count up your denominator, count for your numerator. Good. So we have 2 out of the 5 parts unshaded there. So we're going good. We're going good. Go again. Next one. 6 equal parts. Denominator, good. And 2 unshaded. So numerator is 2. Denominator 6. Our fraction 2/6. Last one in this particular set. How many do you have? What is your numerator? What is your denominator? What's it looking like? Right, so we have 3 unshaded out of 7 equal parts. Good. So we finished finding the fraction of the unshaded shapes. Now what we're going to do is we're going to do a few sets, and we're doing the shaded part of those sets. Good? So right. So we have different shapes in each different box, and we're going to find a fraction of the shaded shapes. So in our first example, or first question, I should say, how many parts would make up our denominator? We have 1, 2, 3, 4, 5, 6, 7 parts. And out of those 7, how many do you see shaded? This is the first one, the only one I'm doing for you all. So we have 5 shaded stars out of 7. So we have 5 sevens having been shaded. So now that I've done one for you, you all are going to do this one for me now. So we are dealing with this set of ovals here. What I want you to do, find your denominator, find your numerator. We're dealing with the shaded set. So the shaded ovals will form your numerator, and of course we know our denominator is the entirety, it's the whole. So how many parts make up your denominator? How many make up your numerator? Write it down, don't forget your vinculum line, form your fraction and see if it's the same as the one that's about to come up. Right? So hopefully your denominator was 10 and your numerator was 6. That would mean that you formed the proper fraction from this particular set we are dealing with. Good. So this one here, different shapes, but it's all part of one set. Find your denominator, find your numerator, and see. So from my view, the denominator here should be 6. Our numerator would be, good. So we have 3 out of 6 parts in this one. Excellent. 3 have been shaded. The total is 6. So we have our numerator, we have our denominator, we have put in our vinculum line. Count the next. So remember, we're only counting the rectangles on top, the boxes for the answer, but I just made it bigger to make sure that you all saw. So good. Our denominator would be what? And our numerator would be what? Good. So 5 have been shaded, and it's 9 in total. So 5 out of 9 equal parts, 5 ninths. Next set. Count it. Double check if you're not sure. Check for your denominator, your numerator, everything. And our fraction will be, right, so this time it's 5 out of 8 equal parts, 5/8. There were 5 that were shaded. Last one to the bottom now. Count it up, all the different triangles. See what you find, see if you go, and as our reveal, hopefully you got all correct so far. And our last one, 4 out of 9 equal parts, 4 ninths have been shaded in that particular set. Good. So we are almost done. Let's use a few situations and see if we can get some fractions out of it. So read along. Jane's mother bought a large pizza. Once again, we're talking about food. Cut into 12 equal slices. Jane ate 4 slices, and her brother Steve ate 3 slices. So we're answering 2 different questions here now. What fraction of the pizza did Jane eat? What fraction of the pizza did Steve eat? Good? So let's see. What is our denominator? We have the pizza, we have the worded problem, see it here now. So Jane's mother bought a large pizza cut into 12 equal slices. That 12 there will be our what? We know that we have the pizza, it's been cut up. That's our denominator, very good. So Altogether, they would have eaten 7 out of the 12 slices of pizza that they were initially. And you can also make a fraction of the amount that they were remaining. So it all depends again on what is being considered here now. So, next one. Philip bought 7 bananas. His sister Judy ate 4 of them. Write a fraction to show how many bananas Philip has left. So this is what I was talking about. We're not talking about the set that she ate. We're talking about the set that has remained. So our denominator, which of these numbers here would be our denominator? If you said the 7, then you're going good so far. So we have our set with 7 in it, 7 bananas. Denominator 1 time. Draw your vinculum line. Now, his sister Judy ate 4, but are we dealing with how many she ate? No. We are dealing with how many there are left. So, we had the 7, 4 were eaten. Check and see how many you're supposed to have remaining. See if you could figure it out. 4 have been eaten, and there are 3 remaining. So, a fraction, fancy little tooly fraction, would be 3 out of 7 equal parts, 3/7, because that's the amount that there is remaining now. Excellent work. So, as usual, let's do a little review. Make sure that we have everything covered. So, a fraction is an equal part or equal portion of a whole, right? It has 3 main parts in it. We have the numerator, we have the vinculum line or the vinculum, and we have the denominator. Numerator is the number on top. Remember that. It talks about the parts of the whole that you are considering, right? The vinculum is the horizontal or the line going across that separates the numerator that you have from the denominator that you have. And the denominator is the number under the vinculum line, obviously. It shows the amount of equal parts that would have made up your whole from either your shape or your set or whatever it is you're dealing with. Good? So hopefully you will learn something new or refresh the knowledge that you all already have. And if you all need more, get your parents to visit learn.moe.gov.tt for your ECC primary and secondary school needs. Goodbye.